Good Monday, kids. We're going to finish up this lesson today as far as information. And today, what we're basically going to talk about is density. So, if you are at home, I'd really like for you to get a sheet of paper and something to write with so you can jot down some things as we're going through our information. All right, so we're going to look at what density is. And again, as with the previous PowerPoints, our keywords for this lesson, and you really need to focus on those, are mass, well, matter, then mass, weight, and volume. Now, our last vocab word or last term we really need to know is density. And density is this: mass and volume are related to each other, for they help us calculate the density. So you need mass and volume in order to get density. The exact definition of density, it is a measure of the amount of mass for the given volume of an object. So you take the mass and you divide the volume and you get the density. Okay? The amount of density that you have will not change regardless of the shape of the object. So for instance, if you have a piece of paper, like hopefully you got out to jot some notes down with, if you rip that in half, the density is still the same. The mass would go down and the volume would go down, but the density would be the same. All right, so I want you to look at this demonstration or this example picture here first. I know you guys can read, but it says the tomato and the pile of feathers have similar masses. And as you can see on the balance, they have the same mass. Okay. But the tomato is a lot smaller. It has less volume. So that means it is more dense because it doesn't take up near as much space. So if you ask yourself, what is density? Maybe jot something down here for a second. Stop the video if you have to. All right. Density is the amount of matter in a given amount of space. Or you could say the amount of matter in a given volume. So let's look at these three examples down here. Which one do we think is more dense or have a greater density? So if you have a golf ball and a table tennis ball, they're roughly the same size. Which one do you think would have more mass? Okay, the one with the more mass would have more density or would be more dense, and that is the golf ball. Okay, second example here. We have an empty milk carton or a milk carton full of milk. Well, your first question is, are they the same size? Yes, they'd have the same volume. Which one would have more mass? Well, obviously the milk carton full of milk. Okay. And lastly, we have a foam ball or a baseball. So think of like a Nerf ball or something and a baseball. Which one would have more mass? The baseball, and it is more dense. So those are three great examples. Okay, so how do we determine it? Okay, I'm not going to freak out or really focus on you making sure you know these units, but it's something you're going to really need to know as you go on up through your science careers. But mass is usually shown in grams, and the volume would be in cubic centimeters. You see that cm3 as the exponent, or milliliters. So that's what you'll see when we work through these problems. Some of you who are hybrid and have been to class, I've talked about don't break my heart. So there it is again. We have the heart and what appears to be an M on the top and a V on the bottom. So if you need to remember that way, I think it's a great way to remember it. It's how I've always remembered it. So density is mass over volume, or don't break my heart. Okay, this is just a great example of different elements that are the exact same size, but they have different masses, so therefore they have different densities. So if you were to put this bronze on a balance, or the copper or the nickel or the aluminum, again, they would all have different masses, but they're all the exact same size. So when you would divide the mass by the volume, this is the densities you would get. Again, when you get in high school, you'll be able to identify substances based on what their densities are. Okay, now here's the same thing but different. So I guess it's not the same thing, but these all have the same mass, but look at the incredible range of their sizes. Okay, so the brass is just little. Okay, so this volume would be a lot smaller than going up to the acrylic or even the PVC pipe. Okay, so again, those are just examples of how things can change, but you can identify them through their densities. This next thing I've told my sixth graders for years, when you get in eighth grade, you will be doing a lot with this. And if you could remember it, it would be outstanding. Okay, the density of water is 1 gram per milliliter at room temperature. So if you see anything that has a density greater than 1, it will sink. If it has a density less than 1, it will float. So here we have some examples. All right. Milk, maple syrup, corn syrup, and honey all have densities greater than 1, so they're going to sink in the water. As you go up, those different oils or a ping pong ball all have densities less than 1, so they will float. Over here is an example of 2 different rocks. Okay, they're both igneous volcanic rocks, but one floats and one sinks. All right. Want to go through this problem with you. Again, this is why we had your scrap paper out, hopefully. All right. So we have pumice, which is an igneous volcanic rock. We'll get into all our rock types after Christmas. And they form igneous rock form from when lava cools rapidly. So we have the density, 49.8, and it has a volume. So the problem wants to know, or the book would, as they walk you through it, they always ask, what do you know? Well, we know the mass and we know the volume. Okay. So, and that we want to find density, because the question is asking, what is the density? Well, we want to find the density. So you would write it down, don't break my heart, M over V, and then you just sub in the volume, or the values, excuse me. So mass is 49.8 and volume is 83. Simply use your calculator on your iPad or regular calculator or whatever. It's 0.6. Again, they want your units to agree. So it's grams over cubic centimeters. And so that's how you would label it. All right, now let's try one on our own. All right, so obsidian, which was in the previous picture, it's another type of igneous rock. So let's do its problem. So what do we know? Well, we know that we have the mass and we have the volume. So please, on your scrap paper, let's write that down. The mass is 239.2 grams and the volume is 92 centimeters cubed, or cubic centimeters, however you want to say it. All right, well, we want to find the density. The question says, what is the density? So we want to find the density. Okay, what will our formula be? Write that down, what you think it is. Okay. Sorry, I was behind. So if you write down the formula, it is density equals mass over volume. Don't break my heart. So now take a second and substitute those values in. You know what the mass is and you know what the volume is. So create a formula and you should have written down 239.2 over 92. Then you simply divide with your calculator, and you should get 2.6, or hopefully you did. And again, it's grams over cubic centimeters. And then they want you to make sure your units agree, and they do. All right. We're going to go past this page. Sorry, guys. All right. So this is just a little summary page. I'm having trouble with my lighting. Let's look at question 17. An object's weight is the amount of space it occupies. What do we think? The weight is the amount of space it occupies. That is, oops, I did them both. False. Okay. The amount of space something occupies would be its volume. And the mass of an object is equal to its weight. Well, sometimes it is, but certainly not on the moon or anywhere where gravity is different. Number 19, the volume of a solid is expressed in units of cubic centimeters. Length times width times height. That is true because you have 3 items, so that's why you have the 3. Last question. An object that floats in water is less dense than the water. What do we think? Remember, the density of water is 1. So the answer to that question is true. All right. Let's look at this question, and then you will be done with this for the day. When the astronauts landed on the moon during Apollo 11, which physical properties of theirs changed? Mass or weight? Hopefully you guys know that, and it is weight. All right. That is all for today. You have questions on Canvas that are through a Google Doc. So make sure you open that, answer the questions. Mrs. Stout assures me that you guys know how to open it, make a copy, screenshot it, and submit it. Of course, if not, send me a question on Canvas and I'll get back to you. If you have not tried to get on Think Central yet, you need to do that before Tuesday. Let me know if it doesn't work. Okay, take care. Have a good day.